All right, so we're going to move on to chapter 4, something called apportionment. So this has to do also a little bit with power. Here's an example of what's known as an apportionment problem. So mom has 50 pieces of candy. She's planning to divide them among her 5 children. She wants to use this as an opportunity to teach her children about the relationship between work and reward. So she says the candy is going to be divided among them at the end of the week in proportion to the amount of time that each of them is spent on chores. So the more chores you do, the more candy you get. And if you worked twice as long as your brother, you get twice as much candy. So here are the numbers at the end of the week. The kids very carefully documented how many minutes they spent on chores. Yeah. So I want you to take some time in your groups, figure out how much candy you would give each kid based on these numbers of minutes. Okay, so we have a lot of different answers, and this question is really important when the thing we're divvying up is valuable. So a common place where we see apportionment happens in politics in representative governments. Okay, so let's say we have Parador, which is a small country. It has 6 states, A, B, C, D, E, and F. There are 250 seats in Congress, which, according to the laws of Parador, we are supposed to apportion in proportion to their populations. So larger population, more representatives, smaller population, fewer representatives. So I want to find the correct apportionment given the population figures. So these are the populations of each of the states plus the total country's population. I want to figure out how many seats each state deserves exactly without rounding. So there's 3 methods that I kind of saw various groups employing. The most common one I saw was percentages. So I saw people take the total number, 1,646,000, divided by the total population of the country. And that gives you what percentage of the country's population state A has. So it comes out to about 13%. Was it exactly? Okay, 0.1316. Okay, so if they have 13.168% of the population, they should get 13.168% of the seats in Congress. So we take 0.1368 times 250. Anybody have it? Thank you. 32.92 seats. Don't know how I'm getting what? Right, yeah. So for now, we're just determining their exact fair share, and we'll figure out how to deal with the pieces of seats later. Question. There are 250 seats in Congress. Yeah. Okay, so then we do this for each state. So you would take the 6,936,000 people from state B, divide that by 12,500,000 total people in the country, and that percentage is 6936. 0.55488. So that's 55.488%. So to take that percentage of the number of seats, you do 0.55488 times 250. So I get 138.72. So we could continue doing this, but I'm just going to jump to show you method 2. So, sorry. Okay, so my next method is going to be to solve a proportion for each state. So when you set up a proportion, you do part to whole equals part to whole. Okay, so I'm always going to do part to whole. So C has 154,000 people. That's part of the entire population. The whole population is 12,500,000. Yep. So I have part to whole, but then I'm going to set that equal to what part of 250? Yeah, and then you can cross multiply. So we do part to whole, part to whole. Population, part of the population to the whole population, part of the Congress to the whole Congress. So once you have a fraction equal to a fraction, you can cross multiply. So I have 12,500,000 x equals 154,000 times 250, and I get 38,500,000. Then I'm going to divide both sides by 12,500,000. And I get 3.08. That's the number of seats in Congress that state C should get. Yep, yeah, it's just a different method. Yep, so this is, I did part of the population. It's not going to be enough room there. Part of the population to the whole population equals part of Congress to the whole Congress. And the thing I didn't know was the part of Congress. That's what they were trying to figure out, so we called that X. So we get 3.08 for this one. So, good question. Method 3 may seem like the most complicated when I show it to you, but we're going to need to know it later. So, and it may not. It may seem totally normal to you. It's totally depends on how you think about math. So, okay. So if there are 250 seats total to represent a total population of 12,500,000 people, how many people are should be represented by each congressperson, by each seat in Congress? You got it. 12,500,000 people divided by 250 seats to represent those people, and you get 50,000. Okay. Yeah, 50,000. 50,000 people per seat. So each seat of Congress, each person in Congress is supposed to represent 50,000 people. Okay, we call this thing the standard divisor. Okay. Reason being, we call it a divisor because I'm going to take each population of the state and divide by 50,000. Because I need to know how many sets of 50,000 each state has. Because for every 50,000 people you have, you get a seat in Congress. So I'm going to take each state's population and divide by 50,000. So let's start with D, since that's one I haven't calculated yet. So I'm going to do 2,091,000 and divide by 50,000. 41.82 seats. This was 3.08 and 138.72. Okay, so now this actually simplifies things because now I can do the rest of them very quickly. I don't have to calculate a percentage or solve a proportion every time. I just take the population, 685,000, divide by 50,000, 13.7.
So all our answers would become the same, right? I wasn't able to finish.
Yes, if you do them all with method 1, 2, or 3, they should come out the same. Yeah.
I did A.
Oh, okay, I probably misheard somebody or something. 32, thank you. Oh yeah, so I wrote it down right the first time and copied it wrong. Okay, so then the last one, do 988,000 divided by 50,000, and we have 19.76 seats. So we have exactly given out 250 seats, including, you know, the partial seats that we've given out. So if I add these all up, 32.92 plus 138.72, if I didn't round anything at all, this should add up to exactly 250 seats. So we can calculate the exact number of state seats that each state should receive, but the problem is that you can't give a partial seat. So this is kind of a big problem. Does anybody see a solution? How should I give out the seats? Each state divided by 50,000. Okay, so people who have a big population round up.
Or round to the nearest denominator for all of them.
Okay, just round them all the normal way.
Anything under
Anything
5,
over
round
5,
down.
round up. Or anything round down.
Okay. Yeah, so I would end up with more than 250 seats if I did that.
Take them from the most votes. I would just take from the biggest population and just
Take them away from the biggest population.
Yeah.
Okay, so some people suggested give them to the states with the biggest populations, and now I'm hearing take it away from the states with the biggest populations.
already the most represented.
True, but they deserve that representation. They have a lot of people. It's a difficult question, right? And there have been several historical answers. Before I give you the first one, we'll do a little bit of vocab. First of all, a standard quota is the exact number of seats each state should get. No rounding. Okay, that's your standard quota, the exact number of things you deserve. The lower quota is your standard quota rounded down. No matter what the decimal is after, whether it's above 0.5 or below 0.5, you round it down, and we call that thing the lower quota. And if you round it up, that's the standard quota. Rounded up is called the upper quota.
Round everything down and appropriate the rest of the least represented.
Okay, so round everything down, and then to figure out who to give the leftover seats to, that's actually our first historical method. But before we get there, One thing I should point out is we have this thing called the quota rule. No state should be apportioned a number of seats smaller than their lower quota or bigger than their upper quota. So if you deserve 5.6 seats, it makes sense that you're either going to get 5 or you're going to get 6. And you shouldn't get anything other than that, right? You shouldn't have to get 4 or be given 7 for some reason. So this is just sort of a basic fairness thing. Okay? When it happens that a state gets too few seats, we call it a lower quota violation. And if a state gets too many seats, we call it an upper quota violation. So our first historical solution is called Hamilton's method, named after one of our founding fathers who invented it. Okay. Yep. So we calculate each state's standard quota, okay, the exact number of seats they deserve, round them all down, give each state its lower quota, so its standard quota rounded down, so you just chop off all the decimal parts. Then we're going to have some leftover seats. We're going to give them out one at a time to the states with the largest fractional parts. So to the state that was closest to getting another 50,000 people, they get one. And then the next closest gets one of the other extras, etc. No, it doesn't have to do with population. It has to do with the decimal piece that got chopped off.
Oh, so the .92 would get a seat.
So the .92 exactly would be first in line for an extra seat because they're really close to another whole seat. Yeah. So these are all the quotas that we calculated a minute ago. We're going to round them all down. Yep. And when I add those up, I only get, let's see, 140, 170, 173, 146, 246. Thanks. So I'm actually four seats shy of the 250 I have to give out. So I have 4 seats left to distribute. I'm going to distribute them based on the fractional piece that got chopped off, the residue.
So you do the .92 there?
Yeah, so the .92 is going to get an extra seat. They get the first extra seat.
You round it down.
When I add up all this 32 plus 138 plus 3, etc., I get 246. So it's 246 seats, which is 4 shy of the 250 left over. So .92 gets one. .82 is going to get the next one. 0.76 and 0.72. So that's how I decide who gets the seats.
So do you want 1, 2, 3, 4 there?
It doesn't matter. You can just put check marks. Yeah, you can, or 1, 1, 1, 1. Yeah. Because, yeah, that can be confusing. I don't want you to think that you're giving them that many seats. Yeah. So the final apportionment, State A is going to get their lower quota 32 plus an extra seat, so they get 33. Then we have 139, 42. This State C didn't get an extra. They just get their lower quota of 3. 13 and 20. That gives me my 250 seats. So what do you think? Is it fair?
Yes. Yeah, I still feel that C is underrepresented.
Okay.
I know it's accurate to the method. I just feel like they don't have enough.
Okay, so you try one. Carry out Hamilton's method. Decide how we're going to apportion 250 faculty positions. So we're reframing the question. It's the same kind of question, but instead of seats in Congress, we're giving out faculty positions to, instead of states, schools. Okay. So the schools are the states, faculty positions are the seats in Congress.
So is S the total?
Nope. 12,500 is the total. It's not in the table. You might want to add it.
12,500.
Okay, so a few groups are starting to finish, so I'm going to put the answers up, and if you're not done, you can finish and just have them to check. So how many faculty positions do we give to A? 30
Wait,
total. Yep, skipping right to the end. Yep, 33. B,
15,
E,
42,
H,
21,
and S.
139.
There you go. So that is the final apportionment, skipping all the work. If you haven't finished yet, keep working on this. But how do you feel about this? What's good about Hamilton's method?
It's always the same.
Okay, always the same. Consistent. That's always a good thing. What else do you like about it?
Easy.
Easy. Easy, quick to explain. So you can explain why you're giving certain seats to certain states so that people aren't like, accusing you of doing shady math, right? Fuzzy math, that's what they say, right? The politicians.
So I have a question.
Uh-huh.
Like on the exam that you're gonna give, are
Yeah.
you gonna like do method 1, method 2, method 3?
No, you do your favorite method.
Really?
Yeah.
Okay, awesome.
Yeah, often I'll show you several methods, but I'll never make you choose one.
So
Yeah.
it's not gonna ask like do the method 3 method
No.
get.
All labs the same. I can prove what you did.
Yeah, right. No, I would never do that.
Okay.
You can always do whatever
all
works
the
for you.
stuff we've learned so far.
Yeah. Yep.
Okay.
Anything else about Hamilton's method that you like? Fair? Does it seem fair? It seems pretty fair and reasonable. We will see what's wrong with it next class.